Failed with major repairs. Technical repair report for bidding. Restoration with permit by a fully licensed vendor. Engineer oversight. 3 site visits. Certification with owner liability in lieu of a load test. Load test still may be required by the AHJ.
Fire escape engineers inspect the summary video. This is a multitude of interconnecting fire escapes, connecting many fire escapes or many buildings. But this particular building or fire escape takes care of just this building and then connects to and goes out on the next building down at the ground floor. Primarily the biggest issue is a bad paint job, but it's got a paint, but it's got a bad overcoat. Number 2 was a full refurb. Every single bolt got changed, but they left a lot of bolts behind. Photographs will show that they changed 95% of the bolts, but they left a bunch of the original square head bolts. A lot of the top stringers, they never changed any of the bolts. Some did half and half, as well as the bottom of the stringers. Spacers on these gratings, as the pictures will show, are starting to separate. Some cement work, minor. And on the treads, some of the treads, the spacers are also gone. But the key is that they paid for a full refurb on this, I'm sure, but they left 5% of the bolts behind. Structural, I'll give you an example on this one. It's got lead paint. No bolts changed at all on the top of this stringer, and every single bracket, every single one didn't get a bolt change. Everyone has the original bolt on these. Here, as you can see, and then they changed the top ones which was visible. Also, all the cement was done, but some of the tops were not done, but pretty good. You know, a little bit of more cleaning up on the cement, but the majority of the cement is very good. And the paint job, like I said, it was a dirty past brushing. I don't understand this, but it looks like it was, you know, just enough to turn the black into a gray. So I don't know if this was a primer and then they forgot, but again, this primer and this gray and black, so there's no rust. Some minor rust here and there. I don't think they silicone shut anything. Oh, and I just noticed on a couple of this, they left the rust inside. See the rust inside? They changed the bolt, but they left the rust inside. So I'm sure, yep, they left the rust inside this one. Yep, that's something that's kind of typical. As you get higher to the top, you start cheating it. Full of rust in here. Yet they changed the bolt, but they've left all the rust. So one of the things you want to do is you want to find out who signed off on this. Full of rust jacking, and this one, full rust jacking, yet they changed only the bolt. So that's typical as you go up higher. Yep, look at that full rust. 1/4 inch to 3/8 right there. 1/4 inch on this side. So as I go down, every tread needs to be checked, but looks like every tread on this entire staircase, they changed the bolts, but they did not remove the tread in its entirety to remove all that rust and then seal it with silicone. None of these connections look like they've been backed up with silicone, just to make sure. So some cement work, as you can see here, and in other areas that the photographs will show. But a lot of times, 95% of them have new bolts with washers, but a lot of times they did not change some other bolts. Look at all the rust on that lower shoe, rust on that lower shoe, all original hardware, 50, 75-year-old hardware. And then you come to here, cement work, changes, original hardware, see, original hardware there, all the original supports. But again, they changed every single one. But on some of these treads, it looks like these treads stayed in place. They did. Every single one of these treads stayed in place. They just changed the bolts. Fast and dirty, quick and fast when it comes to the bolt change, but they left all the rust behind. So a lot of times that means, hey, I'm seeing at least 50%. Could be as high as 75, but at least 50%. But the spacers are starting to become an issue, and that means we can't guarantee that this last piece of flat won't pop off. Okay, so we're going down, rust jacking everywhere on the treads that they were left behind, and that's probably around 50%. And some of the clips, see, they know how to change it. They changed it here. They changed all the lower shoes here. Changed all the bolts, changed all the bolts, changed all the bolts. But then, you know, because nobody was double checking their work, they got away with a few. Okay, so spacers on the gratings, those need to be talked about because those need to be either reinforced or replace the grating. It's cheaper just to reinforce it, get all the rust out of this. But as you get closer down, they started doing real good work. They made sure every bolt got changed. Okay, and the one thing I wanted to show is over here why you can't leave any original hardware behind. Look at here. I'm going to zoom in. See that? That bolt is there, but it's gone. Okay, and on the bolt above is actually more spacing. Okay, so again, no supports. The bar that comes out and picks up the nose, none of those were swapped out on any of this. Here's one where they changed some of the bolts but left the originals there. Switched those bolts but left the originals there. Original nut full of rust. So there's a 25% failure on the structural. There's rust building on that foot right there. As you can see, they have to open that up, and because otherwise, by the original hardware there, as you can see, original hardware there. Okay, so they know how to change whatever was convenient, but then what was hard, they didn't. So it looks like they left a lot of the rust. As you get closer to the ground, a lot of times there is no rust in the treads, because it's the higher you go, that's where you see all the rust. But string, the stringers and the treads, everyone that got new bolts. So I see 95% change of all the bolts. But look at the shoe down here, all original hardware and rust jacking. All original hardware, rust jacking. This is all welded. The tie back in, because they didn't verify that back into the wall, the cement is spalling, they just put this little clip. That's not allowed. That's supposed to be a 3/4 embedded through bolt into the building, or in a Hilti epoxy bolt, 3/4 minimum, going in 8 to 12 inches deep into the building if you want to not rebuild these connections back into the wall. This looks like an extension. That's a rain roof, kind of very badly made. It's done its job, but the key right now is this corner here. Wall welded brackets. Sistered pieces were welded. You have to have them with a gusset plate and bolts. Sistering is not allowed on major structural, and that angle is like a 2.5 by 2.5. That should be at least a 3 by 3 by quarter, if not a 4 by 4. That's going quite a long way. Totally undersized, and picking up this crazy corner here. So this whole thing needs to be upsized, just to avoid, because there's a lot of structural load in this piece. This is here, some issues with some trip hazards coming here, going down now. They have a leg here made out of a tube, not properly supported, and they have it on this side with just a simple tube. So that has to be at least a 3 by 3, if not a 4 by 4. 3 by 3 by quarter, 3 by 3 by 3/8. The engineer will help us with that sizing. A lot of welding, just need to back it up with a bolt. Major structural. You can shop weld this railing, but you must field install it with a bolt. These pickets can be welded, but it must be field bolted. That's the standards when it comes to the procedures and guidelines in all fire escape fabrication. Grading, all welds. This should have a clip here, otherwise we have to load test. Well, we need proof that this was done by a certified welder, and these are not certified welds. You can just tell a lot of melting of rods here. So to avoid having to play that game, we just put an angle clip here with a bolt and a bolt. We negate some of this stuff. Going down, new grade, new treads here. Oversized, bolted. Okay, they should be sealed whenever possible. Try to seal. See all those cracks and crevices? Water's going to get in there and destroy this. Water's going to get in there and destroy these treads, and then we can't sign off on these things. Okay, this down here can't just weld it. You need an angle clip. An angle clip. Anything that's a rigid joint that needs to move. See this welded bracket? You need to bolt it. And the tie back ends into the building. They're using all these little baby. This is not the norm that we would use to tie back in, but. And again, you need to seal it. But as you can see, welding and bolts, which is acceptable, bolted. But look at this weld and look at this weld. You know. So as soon as you stop bolting, the norm for all fire escapes is to have bolted connection. And 95% of this fire escape that ties into the neighbor is bolted. 5% is welded, so that's the only thing that needs to be backed up. You want to seal these joints from above. You want to, and as you can see, she's not tied into the ground. It must be fixed to the ground, and fixed to the top. Okay. You also have rust jacking happening in here. Look at that. So you need some work on this cage. Continuation of the video. So this all needs to be cleaned because it's rusting out. It's going to definitely deform this area, and we're not going to be able to lock up good anymore. The whole cage is kind of buckling. A lot of it's cheaply made, so it needs some reinforcement. It's just standard flat. So it's an inexpensive mesh piece that just needs a little bit reinforcement. She's starting to pop, and you want to find out if people can still break in. A weak point is right here. I climbed here to here, and then I climbed along the side and I jumped in. So you may want to consider additional 5 feet or more, or some sort of physical barrier down that other end in order to address this break-in. But the fire escape does not pass inspection. She needs some spot painting on the fire escape only, so that's the only thing you really need on this fire escape. She has been kept painted. I'm just dealing with this side and this portion to here. Structurally, she's got a 25% failure rate on the structure. Okay, and that's, you know, old bolts left behind, some rust jacking and some of the treads you gotta pop and identify. So it does definitely need a technical repair report so we can identify every one of those treads and mark it, or work with the vendor who gave the certificate on this to have them come back and finish the job correctly. That's probably the best. Some resupporting there. So she may go 25 to 50%, but 95% of all the bolts have been swapped out. The remaining work is probably going to amount to about 25%. Some cement work, 25%. Structural treads, change some of the bolts that were left behind, re-beef up these posts. So I'd say about 25% structural on this, and then we can certify the fire escape. And then again, work on the cage down here. If it's all spot work, if you're looking at 25%. It's all, if you want to really beef up something more here, or redo this piece here, you might be looking at a 25 to 50% on the structural. But otherwise, she's currently ready for its intended use. Any questions, Fire Escape Engineers, 866-649-0333.
Load test still may be required by the AHJ. Failed with major repairs. Technical repair report forbidding. Restoration with permit by a fully licensed vendor. Engineer oversight. 3 site visits. Certification with owner liability in lieu of a load test. Fire escape issues. Photos represent what the violations are, not where they are or how many exist. Pass-fail inspection, not technical repair report. Please call us with any questions. Thank you.